section 12.3. We're going to talk about some more constructions. Go ahead and share my screen for you. You guys know the drill by now. So in this section, we're going to do some constructing of angle bisectors, parallel lines, and perpendicular lines, and talk about some angle bisector properties. So constructing an angle bisector. So first of all, you'll be given an angle. You're going to open up the compass. You're going to make an arc, and that arc needs to intersect both of those rays. Keeping the compass the same width. Okay, don't change your compass. Put it on the intersection of where those arcs intersect those two rays. So move the tip up there to B, make an arc, then move it down to C, make an arc. Where those two intersect, that will bisect your angle. Remember, bisect means to split into two equal parts. That's what's called a rhombus method of doing this. Because we left our compass the same width the whole time, we basically constructed a rhombus. And then the diagonals of a rhombus bisect each other. So, all right. Constructing parallel lines. We have two different methods for this. We have the rhombus method, then on the next one we have the corresponding angle method. It really is going to come down to whichever technique you prefer. I tend to prefer the rhombus method, sometimes called the angle bisector method. I don't particularly like the corresponding angle method. I think it's a little too complicated, but if that's what speaks to you, then that's what you got to use. Okay, so constructing parallel lines. So first, you're given that line, L, little curly L there. You're given that line. So I want you to make some kind of line. So make a line there that's going to go through point P and cross line L. Okay, we're going to need that line because basically what we're going to do is bisect the angle. So what you can see here is that this is really the exact same thing as the angle bisector construction. That is because those sides of that rhombus are parallel. So in constructing that bisector of that angle, we're constructing that line up top that is parallel to that given line. So in constructing that rhombus, we're constructing parallel lines. So that's why I dig this one, this construction more so than the next one, because it's really very similar to this one. Notice the difference is where we connect. So here we actually bisected the angle. So we made a line segment that split the angle into two pieces. Here, we didn't connect. See how we got that arc right there? We didn't connect that to A. If we connect that to A, there's your angle bisector. But we didn't. We connected it to P. So by connecting those two together, blammo, parallel lines. Got it? Cool. Another way of constructing parallel lines is called the corresponding angle method. So what this does is this uses the congruent angle construction. So you start off the same way, make a line that's going to cross L and go through P. Then we make an angle, right? So we just an angle going through P, so we make an arc going through P. Then we move the tip up to point P, make the same arc. We go back down, we measure the width right there between P and that arc. We measure that width, make a little arc there, come up here, put the tip right there, make that exact same arc. So your compass needs to be the same from this arc to this arc, and it needs to be the same from here to here. So what this is doing is constructing a congruent angle, and those two angles are corresponding angles. So remember that when you have parallel lines cut by a transversal, those corresponding angles are congruent. So we're working backwards from that. We're constructing the congruent angles, therefore forcing the lines formed to be parallel. Now, constructing perpendicular lines. There's going to be two different ways of doing this one. Now we've got the perpendicular bisector. That's a perpendicular line. Now you can see this one is constructing a perpendicular to a line from a point that's not on the line. So you notice how we want the perpendicular line to go through point P. It's not on the line. The next one is constructing it from a point that is on the line. So your book didn't bother going through the two different ones. So that your book did this one, but not this one, but they're both important. You need to do both of them. This is really just the perpendicular bisector construction. So here's the thing. If you know a few basic constructions, like copying a line segment, copying an angle, perpendicular bisector, a lot of those, bisecting an angle, a lot of those then build off of. So if you memorize those and you know how to do those pretty easily without having to continually flip back and look at steps and stuff, then those are easily built upon. And it's not just about memorizing these. It's about understanding why you're doing what you're doing, why the compass stays the same throughout, you know, why the compass stays the same from here to here, and what that really is forming, and therefore why the construction works. So I don't want you to think of it as a bunch of random steps that you have to memorize, because if you do that, it's going to seem a lot more confusing. Okay, so here's what we're going to do. We're going to put the point of the compass on P. We're going to make an arc. It's going to intersect the line twice. Okay, then you're going to move your compass. Okay, you're going to move your compass to where that arc intersects the line. So put that compass on point A. So make an arc. Put it on B. Make an arc. Same compass setting the whole time. You're forming a rhombus. So that line is going to be perpendicular. Let's see, I'm not even reading the directions here. Draw an arc with its center at P that intersects the line 2 points, 2 more vertices of a rhombus with the same compass opening. Make 2 intersecting arcs, one center A and the other center B. So when they say center, they mean that's where the point of your compass needs to go. Because really, you know, it's the center of a circle, right? If you were to make a full thing, but we're just making little arcs. If you're doing a perpendicular line from a point that is on the line, we're going to do pretty much the same thing. We're going to start with the compass on P. We're going to make an arc. Now you can make a big honking, you know, semicircle there if you need to, or you can just make an arc, then lift your compass and then arc on the other side. Now, for this one, you're going to have to change your compass setting. Once you get those 2 points, A and B, are equidistant from P. So now all we're going to do is find the perpendicular bisector of P. So we're going to take the point at A, we're going to open it more than halfway. We're going to make an arc above. If you want to make an arc below, you can. You don't need to. I'll tell you why in a second. Move it over to B, make an arc above, below if you want to. You don't have to. Connected. That perpendicular line should go through where your arcs intersect, point P, and if you chose to make the bottom arcs, all 3 of those should be collinear. Remember what that word means? It means they should all be on the same straight line. But because we have point P, we don't actually need the lower arcs. If you just want to do the upper arcs, that'll be good enough. Okay, so constructing a perpendicular. So I found a summary for us. So through a point that's not on the line and through a point that is on the line. So there's just kind of a summary of the two and how they're similar. All right, example 1, given triangle ABC, let's construct an altitude from vertex A. That's just a perpendicular. So when we say an altitude, we mean that perpendicular from point A through BC. This is a construction of constructing a perpendicular line from a point not on the line. So it's just this construction right here. We just happen to have a triangle. The point not on the line is point A. So we're going to construct a perpendicular to BC that goes through point A. That will be our altitude. So from point A, open your compass and then make an arc. Now here's the thing, depending on what kind of triangle this is, you might have to use your straight edge to extend this line a little bit. So you want to open it up to where your arc hits there twice. Those 2 points where it hits, right there, you see that? Where those hit, you're going to put your compass down there, move it to whatever point right here. They didn't bother labeling that. Make an arc, put your compass on that tip right there where that arc intersected, make another one, and then connect A to that intersection. Your altitude is technically just this part inside the triangle. So sometimes you might see some people erase all this. I prefer if you didn't erase it because I want to see your whole construction. I want to see all the arcs and everything. So don't erase stuff. Leave all that stuff in there. All right, given triangle ABC, let's construct an altitude from vertex A. Now this one we're definitely going to have to extend BC because it's an obtuse triangle. So our altitude is going to be outside of the triangle. So we're going to have to first take a straight edge. Don't do this by hand. Don't eyeball it. This is a construction. Use a ruler, straight edge, something like that, and a compass. Do not eyeball it. Okay? I can tell the difference. I know you may not think I can, but I can totally tell the difference if you eyeball it. So like when I'm grading tests and stuff, I will have a compass handy and I will be measuring everything. Yeah, I'm hardcore like that. So using a straight edge, you're going to extend BC back, and then you're going to do that perpendicular construction again from point A. You're going to open the compass, draw an arc. Now this arc happens to cross that extension twice. It's okay if it crosses the extension and inside the triangle as well. That might happen as well. So the arc doesn't have to be either completely inside the triangle or outside. It can be a combination. And then move that tip of your compass to right here. Make that arc. Move the tip over here. Make that arc. Compass stays the same the whole time. Rhombuses. Given triangle ABC, construct an altitude from vertex A. All right, congratulations, you're done. It's a right triangle. So the altitude is AB. There's no construction needed. All right, properties of angle bisectors. So triangle ADP is congruent to AEP by side angle angle. Okay? Shared side AP, and then bisected angle A, and then the right angle. Any point P on that angle bisector is equidistant from the sides of the angle and vice versa. So just to try to show you what I'm talking about, these distances right here are the same. All right, again, I put the links to the constructions on here. I will go through and put the times on there as well, the little timestamp in there, so that you know what you're up against when you watch those. Most of the constructions tend to be kind of short. Some of them I have trouble finding, so if they end up being, like 2 or 3 minutes, but I try to find some that are no more than a couple of minutes long for you to watch. All right, so there's the links to the video instructions. Remember, these are not the ones that I did. I am not reinventing the wheel. If I can find it from somebody else doing it, I am using their stuff. Okay, so I think that just about does it for this section. So it's a lot of the same constructions, just in a different setting. So I hope that you guys can see that. And I hope that I've done a decent job of pointing that kind of stuff out for you. So, all right, well, that is the end of section 12.3.